Hello and welcome to this tutorial video on variables and data types in Java. So here we see a picture of a bunch of different data types, and what I'd like to do is I'd like for us to think real quickly about how each of these pieces of data that are displayed haphazardly on the screen are different from each other. Hopefully you were able to see that, one was a picture and one was a kind of a small phrase, and then one was a decimal number, and one was a number without decimals, and then you have this word false, which we're not even really sure what that means. Well, in Java, when you make a variable, we're going to set these variables equal to something. So first of all, we have to talk about what it means to make a variable. To make a variable, we're just going to start typing some words and maybe numbers and maybe other symbols in there that will help us remember what this variable represents. So here's some conventions in Java. You can start out with any upper lowercase letter, the $sign or the underscore symbol. You don't really use $sign and underscore. Those are for special situations. And then you can add in, after the first letter, you can add in more letters, digits, the $sign or the underscore characters. The only thing you can't do is you can't make, when you make words out of these, you can't use a reserve word that Java uses automatically. Like, for example, we're going to see in a minute that we use int. We use the reserve word new a lot. There's a reserve word that's called main. These cannot be made as variables and assign stuff. By convention, we will start a variable with a lowercase letter, and then we will add other letters and numbers to it. Usually our variables come out to be words, and sometimes they even come out to be multiple words. So if you're going to use a multiple word variable, the first letter by convention is lowercase, and then each word after that that's contained in your variable can be capitalized, and this is called camel case notation. And if your variable stores any constant values, then the convention changes a little bit. You capitalize every letter, and then you separate the words with the underscore character. So we'll see some examples of that in a second. So here's some examples of some good variable names. Usually variables try to describe what you're doing with that variable, what you're storing there. And then on the other side, you see some bad variable names. 1, 2, 3 starts with a number, string is a reserve word, and my best friend has spaces in it, so that's why all of those are bad. So in Java, we create these variables, and we talked earlier about data. Well, these variables will store data, and we're going to talk about two different types of data. There's a primitive data type, and then there's a reference variable. Variables that'll store primitives versus variables that'll store references. So in Java, a variable either stores a numerical value or of some type, or it stores a memory address that refers to an object. Primitives are the ones that store values. So from our earlier example of all that data, 12.4287 and 5 and false, those would have all have been primitives, and they would have been stored in primitive variables. Objects like strings or images, they will be stored as a reference, and that reference will actually end up being a number. That variable will hold a number that's a hexadecimal number, and it actually references where in memory that object is. And we'll talk more about reference variables later in the course. Right now, we're just going to focus on primitives, and we're going to focus on these three primitive types: ints, doubles, and booleans. Here we see the integer, decimal, and booleans that represented, and the syntax. So double, as you might have guessed, is what we use to represent our decimal numbers. And then booleans are the true or false values. So you actually set them either equal to true or false. We'll talk about that in a second. When you're making a so syntactically, this is how you would initialize. You would start out by naming the variable type, creating the variable name, which we've already talked about the conditions, and then we would assign something to it. Here's the equal sign, that means assignment, and then we're going to stick 5 into x. And since it's a primitive, x actually stores the number 5. Y actually stores the 3.12, and is odd actually stores true. when you make a variable, you can also declare it to be final. And if the variable is a final value, then once you assign it, you can't change it. And so here we have max integer value is equal to the maximum value you can have for an integer. We'll talk about why that is in a second. And notice that the naming convention changed. I did max underscore integer underscore value. And so all the words are separated by underscores. Whereas when I was just creating the variables up here, is odd, I used camel case notation. The two words is and odd. Is was uncapitalized, and the next word that I had, it started with a capital letter. And that's called camel case notation. All right, so let's talk about the three different types that this course really dives into in terms of primitives. The first type is called an integer. We use the reserve word int when we're declaring and assigning for an integer. Integers have 32 bits of memory. So Java actually reserves a certain amount of memory in your computer every time you declare an integer. And when you declare an integer, that amount is always 32 bits. Because of this amount, then that means that they can store a value between negative 2,147,483, negative 2,147,483,648 to 2,147,483,647. So anywhere in the range is a valid thing that you can store into an integer. Now, you might be asking, why such odd numbers? Well, let's think about it for a second. I'm going to pull over a calculator here, and we're going to look at the concept of where those numbers came from. So if I have a binary digits making up my number, that means I'm base 2. And if I reserve 32 bits for that, that means if I raise 32, or if I raise that base 2 to the 32nd power, then that's going to give me that many combinations, a little bit over 4 billion. And if I want to store numbers, that's how many different numbers I can store. Well, about half of those numbers are going to be negative and about half of those numbers are going to be positive. So what I need to do is I need to divide that value by 2, and that gives me how many different numbers on each side, except for you might be saying, well, hey, the positive value is one less than that. Well, we had to account for 0. So I said, let's have negative 2 billion and something negative numbers, then have 0, and then 2 billion and something positive numbers. And since I used the 0 to be one of the positive numbers, that's why the actual positive numbers have one value less. So in an assignment, this is the biggest number that you could give to an integer, and this is the smallest number that you can give to an integer. When we make doubles, we use the reserve word double, and it's lowercase, just like int was lowercase. Excuse me. And they are assigned 64 bits of memory when declared. So that's 64 bits is not twice as much memory. 64 bits is actually 32 times the amount of memory that we had. So we can store a number from very, very small to very, very big. I'm not even going to go into what the actual details of the smallest and largest decimal numbers are. Suffice to say that they're small and big enough that you probably won't ever have any problem with it. And there's actually a programming format that's used to store these numbers that we're not going to go into in the concept of this course. However, you can, just like normal, create a variable that's of type double, and then you can put a double into it. And I can do this with as many different variables as I want. Here's 2 examples. Here's some of that camel case notation that I was talking about earlier. Finally, we have booleans. Integers, I'm sorry, this should say booleans are declared with the reserve word boolean, so that's a mistake in this slide. They are assigned 1 bit of memory when declared. They can store either true or false. So since there's only 2 values that I need to worry about, 2 to the first power is 2. I only need 1 bit of memory for booleans, and a boolean you can either say it's equal to true or equal to false. There's no other way that you can say that. So Java is fun was true and is valid is false. So the other thing you got to worry about when you're working with data types is mixing stuff up. Obviously, you can't put anything into a Boolean other than true or false. However, you can put an integer piece of data into a double data type. When you do that, the data is going to print out at a point, it's going to add a 0.0, it's going to add a decimal place to the printout, but you can do it. You cannot, however, put a double into an integer data type because there's a loss of precision there. It doesn't know whether or not there was any decimal numbers after the number. So even if it were a double declared as 5.0, you couldn't put that double into the integer data type. You have to have an integer go into an integer. So here's some examples. I create an integer that's equal to 5 and a double that's equal to 3.14, so we have x and b. If I say int a is equal to 3.14, that's not legal. I can't take a double and put it into something I've declared as an integer. However, if I say y is equal to double y is equal to 3, that's perfectly fine. I can put an integer into a double. Here I'm going to try to create an integer variable c, and I'm going to try to assign it a variable which that variable's data type goes with it. So double b was a double. I can't put a double into an integer, so that's not legal. However, if I want to reassign the value of y was an integer, and y was a double and x was an integer, so I can take the integer x and put it into the double y. So that's perfectly legal. So what I'd like for you to do right now is I would like you to go to your Java coding area in Replit. I've given you the link. And what I want you to do is I want you to go through and on lines 7, 8, and 9, I want you to assign to X, Y, and Z what you think would be the most appropriate type of data given these 3 different pieces of data on line 6. I'll go ahead and give you some time to do that now. Hopefully you were able to assign the value 8 to X and the value false to Y and the value 3.14 to Z. And then when you go ahead and run this should all work, and you should see it now prints out that X was 8, Y is false, and Z was 3.14. So interestingly enough, and we'll talk more about this at a later date, but when you have variables that are primitive in nature, a lot of times there's operations associated with these variables, and you can perform these operations on these variables. For example, I could add the values of X and Z together. I could also multiply the value of X and Z together. The best way to see that in action is to go ahead and let's print something out. Let's print out the value of X plus Z. Those are both doubles, or no, those are both primitive data types, and they're both numerical in value, so it should be able to perform the addition operation on them no problem. So when I run this, we should get another line up here, and sure enough, when you add 8 and 3.14, you're going to get 11.14. And I can make that multiplication or division, and I will still get a solution. I'm not sure in my head what the multiplication of those two numbers is going to be, but let's run it and see if we get something plausible. 25.12, that sounds like that's right to me. So there are some very different ways in which you can create these assigned values to these variables, but you can also use these variables in a very practical way. I want to do something kind of interesting with you right now. I'm going to create a new int called, we'll just call it num, and I'm going to assign to num the biggest value that exists for an integer. And as we've talked about already, that's 2,147,000 or 147,483,647. All right, now I'm going to go ahead and make that assignment. If I print that out, just by printing out the variable num, it should print out that value. And so, oops, I forgot to put the semicolon after my system.out.println statement. So yeah, as you can see, it prints out the biggest number. What would happen now if I add 1 to that number? What if I take this number that's a variable and I add 1 to it? You know, like we would expect, I expect the answer to come out to be 2 billion, some millions, some thousands, and 648. But if you'll notice what happens when I print that out, it actually gives me the negative value. So it looks like it adds 1, but it turns it negative. And what's even interesting is if I add, like, say, 11 to it and run it again, now that number has gotten smaller instead of bigger, and it's a negative number instead of a positive. So what's happening here is I've already talked to you about the fact that the 2 billion, the positive 2 billion number that ends in a 7, it is the largest integer that can be stored based on the amount of memory that's allocated for integer variables. When you add 1 to that, instead of giving you an error, it wraps the data around to the next integer that it knows about. So think of a number line, but actually think of a number line that's connected at the two ends, and it's a circle. And so when you get bigger than the highest positive value, it just circles around to the smallest negative value. And so that's how come we went from 2 billion something ending in 7 to negative 2 billion something ending in 8. And that's called stack overflow. That's what a stack overflow is when your data overflows the parameters for it, and it has to do something in some form of way to interpret what you're asking it to do. So, you know, by converse, I could take the smallest variable and I could subtract a number from it, and it would wrap it around and it would become positive again. So you got to be really, really, really careful when you're dealing with these. Like if I multiply this largest integer in existence, if I multiply it by 11, see, now, sure, it's going to wrap it, but it's going to wrap it all the way around. Let's multiply it by a number a little bit smaller. Let's multiply it by, or let's take a number that's a little bit smaller. Let's take 1 million and something and multiply it by 6. And let's see what happens there. And sure enough, when you multiply this number right here by 6, you definitely don't get this number. So you can see, you got to be, as a programmer, you've got to understand the limitations of what your variables store, and you got to be aware that things can overflow, and you could have stack overflow as well. And that's all I've got to talk to you about this subject. I hope you had a good lesson. Goodbye.